Here, we're going to find the slope of a polar curve in the xy plane. In this situation, we're dealing with the graph of r equals cosine 2 theta. And this graph represents what we call in the polar community a rose. We're given some theta values, negative pi over 2, 0, pi over 2, and pi. So calculating the slope means we're basically dealing with a derivative situation. So you may recall in the previous video, but we mentioned that we have a formula for slope of a curve in a Cartesian plane, right? So this is the slope, dy dx, at some r theta point. So if we know that point, r or theta, then we can find the slope in the Cartesian plane. And so I've rewritten our formula here. Dy dx, the derivative of y with respect to x, at any point r theta is defined as r prime sine theta plus r cosine theta, all divided by r prime cosine theta minus r sine theta. So in order to do this, we're going to need to know what those r values are at each of those points given, at each of the theta values given. So in this situation, we can make a table of values, theta and r. I've got negative pi over 2, 0, pi over 2, and pi. And if I plug them all into my equation here, plugging negative pi over 2 into cosine 2 theta, that would be negative pi. We get negative 1. So my r theta ordered pair here is negative 1, negative pi over 2. If I plug in 0, I get out positive 1. Positive pi over 2, negative 1, and pi, I get 1. So that gives me these ordered pairs for r and theta. 1, 0, negative 1, positive pi over 2, and 1 pi. So these are my points that I'm going to use, and I'm going to use those points, plugging them both in to the function r and the derivative of the function, and then also using some theta values. All right, so I took a second to just rewrite this over on a page so I'd have more space to do some work. We basically have 4 calculations to do here. I've got my 4 ordered pairs. I'm only going to do the calculation with the first ordered pair. Okay, so in order to do this, though, we need to know what r prime is. And r prime, the derivative of cosine, is negative sine of 2 theta times 2. Or just rather negative 2 sine 2 theta. All right, so what this does is this changes my slope formula just a little bit. I now have negative 2 sine 2 theta times sine theta plus r cosine theta over, again, negative 2 sine 2 theta times cosine theta minus r sine theta. So in order to determine slope at these points, I'm going to plug in my theta and r values. I have negative 2 sine of 2, negative pi over 2, sine of negative pi over 2, plus my r value, negative 1, times cosine of negative pi over 2, all divided by negative 2 sine times 2, negative pi over 2, times cosine negative pi over 2. And then we get minus negative 1 times the sine of negative pi over 2. So noticing in the derivative one, those 2's cancel, we really just need to know what sine of negative pi is, and then also sine of negative pi over 2 and cosine of negative pi over 2. So as a note, this is some scratch. Sine of negative pi is equal to 0. Sine of negative pi over 2 equals negative 1. And cosine of negative pi over 2 equals 0. So this will zero out, this will zero out, and this term will zero out. So that leaves me with negative 2 times 0. Sine of negative pi over 2 is negative 1 plus negative 1 times 0 over negative 2 times 0 times negative 1 plus 1, and sine of negative pi over 2 is negative 1. So simplifying this here, we end up with 0 over 1, which is 0. This is a horizontal slope of the tangent line at that point on our graph. And so I think me doing that for 3 more ordered pairs is really busy work. I'm going to tell you what those answers are. Okay, so again, if we have some r theta ordered pairs, we know what the slope is. So for negative 1, negative pi over 2, my slope is 0. At 1, 0, my slope is undefined. At negative 1, positive pi over 2, again, we get a slope of 0. And at 1 comma pi, we get a slope of undefined. So vertical lines have undefined slopes. And if we think about what this graph looks like, I'm going to try and draw this rose by hand without butchering it. What happens is it curves up, it goes through the origin, curves down, crosses through here. At negative pi over 2, we go back through the origin. By the time we reach pi, we're right here. Curves back through. By the time we reach 3 pi over 2, we would be here, and that would be positive pi over 2. And continue along to 2 pi. And so you can see we have these slopes of 0 at pi over 2 and negative pi over 2, and vertical lines that have an undefined slope at 0 and pi. And that's it.